Okay, so let's look at CRS competency 1 and 3. So what it says here is find a linearly independent set of vectors that spans R of A. This is actually the same as competency 2, except you don't need to transpose before you row reduce. So what am I talking about? Let's look back at the two examples here. Here at example 1 and example 2, notice the first step was to transpose and then row reduce. Now if I'd wanted to find the linearly independent set of vectors that span the row space of A, I just wouldn't transpose. I take this and row reduce, and then you get a set of row vectors, and then he defines the row space as a set of column vectors, so you would simply take the transpose of those row vectors, and those would be the linearly independent set that spans the row space of A. Similarly with this one, if I wanted to get the vectors that span the row space, I would row reduce this one, take the transpose. Now if you notice, if you row reduce this one, you're going to get 1, 0, 0, 1, 0, 0, 0, 0. If I take the transpose of that and take the non-zero columns, I'm going to get the columns 1, 0, and 0, 1, and those span the row space. Okay, so there's really not that much difference between competency 2 and competencies 1 and 3. And if you need further information, there are the examples in the book that he works out explicitly, and you can see those there. All right.